Today we're going to be doing exponents. There was a couple of exponents on things that you've seen over the last couple of days, but we haven't really gotten into them. Exponents are interesting because it's a way that you can represent really, really big numbers and also really, really small numbers in a relatively simple way. Okay, and science uses, in 8th grade you get into the exponents a lot more. But this is what's going to happen. We're going to evaluate expressions with specific values of their variables. So that means that we're going to be able to represent numbers in a different way. We can arise from formulas in real-world problems, perform arithmetic operations because we know our math facts, and whole number exponents in conventional order when there are no parentheses to specify a particular order. Because what is the second thing of, please excuse my dear Aunt Shaniqua? Yeah. Exponents, exactly. So we've said it. We just really didn't look into it much. We didn't look into it very much. The order of operations, for example, formulas v equals s cubed and a equals 6s squared to find the volume of the surface area of the cube with sides the length of s. Okay, are we locked out? Are you locked out? Are you? Oh, I was going to mess with her. Thank you so much. Appreciate that. All right. There was... What? Spider napkin. All right. I'm trying to clean off the whiteboard here, and the napkin stuck to the table. Yep, microphone is open, as they say. Actually, the computer records. It just records whatever's happening on the screen. So if I actually do want to put an intro video on my YouTube to show parents what it is. So we have the vocabulary. Let's see here, what side are we at? What you'll be able to do, you'll be able to, let's see, for what you'll be able to do, understand, represent, and express exponents in various forms. So this goes under the what I'll know. What I will be able to do. Yeah. Yeah, just as long as you have something there. What you're going to be able to do, paraphrase what we have. Yeah, express exponents. That's cool. Vocabulary. Uh-oh. There we go. Exponent tells the base how many times to repeat itself. So the exponent's kind of like, okay, who sings that song about the base? Megan Trainor. Okay. Megan Trainor, like she did. Exponent tells the base. You should be writing and not talking. Exponent tells the base how many times to repeat itself. Tells the base how many times to repeat itself. We also have the base, factor that repeats itself, uses multiplication. Factor. Each number multiplied to form a product. Does anybody have activity in here? You guys, can you guys get rid of that atrocity of a garbage that he doesn't get empty? It's the activity period's responsibility to empty the recycle bin. Well, That's fine. I'll see if exponential form. Yeah. Has a base and an exponent. Exponential form. Natural form. Has a base and an exponent. Exponential form. Mm-hmm. Yes. Yep. Yes, sir. Yeah. Mm-hmm. That'd be, yeah, it would be super, super lame, but yeah. Who uses this? Who uses this? All right. When we speak about square feet, square meters, square inches, square miles, square kilometers, or any other area units. In Dr. Hightower's message for the canceling school last Wednesday because of the cold, he talked about how much square miles the district covers, and it was 86, I think he said. 86 square miles. The unit square foot is actually 1 foot by 1 foot, or 1 foot squared, or 1 foot to the power of 2. Okay? To the power of. Now that term there, to the power of, is something that we'll get into right now. Then there's also, if you talk about square-shaped areas, for example, if you say, my room is 12 by 12 square, you're meaning your room is 12 feet by 12 feet, or 12 to the 2 up top, on 12 square feet. That's, yeah, 12 square feet. 12 square feet. So that second, this guy doesn't need to be there. Yeah, yeah. The power of. Yeah, you can think of it like that. Yes. Okay, stop talking, please, ladies. Shh. Yep, 12 by 12, and that's exactly what they're talking about here. Saying 12 by 12 feet, or this. Because we have 1 12, we have our second 12, 1 plus 1 is 2, and it's 12, there's 2 of them. Yes, ma'am? No, this is just, when we speak about cubic feet, cubic meters, cubic centimeters, or any other volume units, so we had squared, now we're looking at cubes. Cubes. Yeah, cubes. 1 cubic foot is 1 foot by 1 foot by 1 foot, or 1 foot cubed, or 1 foot to the power of 3. Okay, that's volume. That is 3 dimensions, whereas 2 dimensions is 12 by 12, okay, or possibly length times width. Cubed is going to be 12 by 12 by 12. Okay? Yeah, that would have been... Oops, wrong way. Oh, that's all right. Yep. Who uses this? Another kind of indirect example is if you talk about extremely tiny or extremely big quantities. For example, the term nanometer means 10 to the negative 9th meter. The prefix nano means the number 10 to the negative 9, an extremely small number. Or, let's see here. So we have 10 to the negative 9th, and I'll show you 10 to the negative 9th. So 10 to the negative 9th. Okay, means that here's my 10. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. Put my What's the matter? Oh, you wanted to come in? Okay. Yeah, we let him in. Decided to let him in. Yes, sir. There are 99 pages that I can write on. Yes. Really? No. Or within a computer, when you see nanobytes, gigabytes, terabytes. Yeah. Because this right here, that's what was huge when I was a kid. This right here was huge when I was in college. And this right here is big in my 30s. Okay? Because it used to be like I'm sure there's going to be floppy disks somewhere hidden in this room. Yeah. Yep. There are disks that are actually hard, and hard disks were floppy. It's weird. Here we go. What does it look like? Or if to put it in better English, how does it look? Or how does it appear? So we have the base, which is 7. Base. We have the exponent, which is 3. Okay? The factor, this is the exponential form. It's interesting. The factors are, there are 7 that's happening 3 times. You see that, how it's 7 cubed? 7 is happening 3 times. We have a 7 as the base. 3 is the exponent. So it's telling you that the base is happening, boom, 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 3 times. That's what that means. Then we have the value. The value is 343, because 7 times 7 is 49, times 7 is 343. Identifying parts. So this is, yeah, you have this on the back side. Yes, sir. Did you? Good. So it's review, and I expect you all to do really well with it. I have no idea why you're all talking right now, because you shouldn't be. So written out, okay, as the factor, we have 7 times 2 is happening. So we have, there's 1, 2, 3, 4, 5, 6, 7 times 2 is happening. You see that? Okay. The base is 2. I'm going to touch this again. Ooh. The exponent is 7, right? So we're up here. It's going to be top left. We're in the top left of your notes. So you should be writing this. Yes?
You can see how someone can get confused. Like if they were to say, you could put 2 and then go 7 times, so it would be 8. Like 8 times.
Okay, yeah. Yeah, just think of the best way to do it is with the base, see how that one's closest to the bottom? That's the one that's going to be touching the bottom more. See how the 7 is kind of up and it's like being lifted, like it's being carried? Okay, that would be one way to remember that you don't got it. The factor is 2 because that's how many times, or that's what the is being factored out. You guys remember we did factor trees? Yeah. Like the first week of class? When you were very scared little 6th graders, and now you're like, yeah, I'm a junior high student. Well, now you're not scared 6th graders in a junior high. Now you're just 6th graders like, okay. Uh-huh. So this is how it's read. 2 to the 7th power. That's how you read that. 2 to the 7th power. 2 to the 7th power. 2 to the 7th power. The value is going to be 128. And I'm going to show you how we do that. Yeah, 4. So now we have 4 times 4 times 4 times 2. 16 times 8 equals 128. Okay? Now, from what we just did, I would like you to do what we just did for 2 sevenths with 3 halves. Do that now. Or 3 squared. 3 squared. It's essentially the base. Oops, sorry. Yes, sir. An x. It's x. It's a variable. Okay. I just did that right here. Did I erase it? Yeah, I found the value. Looks like it's a couple minutes ahead. All right, Sean, what'd you get for the base? Shh, quiet. Okay, these seating chart will change tomorrow. You guys, this U6 over here, or 4 actually, cannot sit next to each other apparently. Okay, Sean, what do you have? 3 as the base. Correct. Okay, Brooke. The exponent is 2. Good. How about the factor? Just go, Brad, Lee. Factor is 3. Yes. 3. Taylor, what do you have for? You have the. Whoa. What do you have for the red? How you read it? 3 to the second power, or 3 squared. Okay. Avery, what do you have for the value? 9. 9. How about how it's written out? Is that going to be on there? No. And it's written out just like this. Okay. 3 times 3. Abby? 9. Yes. Okay. Write this one down because I want to get through this because we're going to have to pick up. Ooh, actually, that would be a good way to have like a little. Yeah. We're going to do this one. I'm going to show you how to do this one. Then those three will be your homework. Then we'll pick up on the notes tomorrow, right at the beginning of class. So for x to the 4th, x is a variable. It means it represents some sort of integer. The base is x. Our exponent is what, Bradley? 4. Then we have our factor, which is going to be just x, yeah. It is read by saying x to the power of 4, or x to the 4th. X to the 4th power. Then our value is what? What? 0? Nope. Well, not necessarily. It could be 0. Andrew? A question mark. Yeah, we don't know what's going to be. It could be anything. We don't know what that variable is. So that's it. And it's written out like this. And you guys finish those 3 boxes. Finish those 3 boxes. Check out your notes and see what the exponent represents. And we will pick up with this where we left off. Yep, sure does.